This is the lecture for section 6B about measures of variation. Consider the following wait times for 11 customers at 2 different banks. So at Big Bank, they use 3 different tellers, so there's 3 different lines, and you can see their times there. Best Bank has only 1 line, and you can see all of their times there. You can then also see a histogram that's been created as far as the wait time for each bank. And then the question asks, well, which bank is likely to have more unhappy customers? And the answer is going to be Big Bank, this one here, because of the fact that there's more surprise times as far as where you're going to wait. Best Bank, you walk in there, you know you're going to spend on average 7 to 8 minutes waiting. That's given. If you walk into Big Bank, one day it can be 4 minutes, the next day it can be 11, the next time it can be 8. This one's going to have a lot more of what is called variation. The first measure of variation we're going to discuss here is called the range. And the range is going to just tell us the difference between the largest value and the smallest value. So to calculate the range, you're going to take the maximum or the largest value and subtract the minimum or the smallest value. Consider the following 2 sets of quiz scores for 9 students. Which set has the greater range? And would you also say that the scores in the set are also more varied? So in this first class, we had 1 student get a 1, everyone else got a 10. In the other class, there were all different scores, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So which one has the greater range? And the one with the greater range is the scores more varied. Well, in the first group, the highest score was 10, the lowest score was 1. So if you take 10 minus 1, 9 points is going to be the range. If I do the same thing for the second set of scores, the largest is 10, the smallest is 2, so the range is going to be 8. So the group with the largest range is in fact quiz 1. But then the second part of the question asks, are the scores more varied in this quiz? And if you go back and look, no, they're not varied. There was just 1 student who did really bad, and the rest got 100% on it. They got all 10 points. So even though this one had the larger range, it doesn't always necessarily mean that the scores are in fact more varied, because sometimes one single outlier can impact just like that mean and draw those things away, make us have a little bit of a different impression than what actually is happening. So we would say quiz 2 group had more varied scores because every single score was in fact different. Another way that we can look at variation is by breaking the data into what are called quartiles. And you want to think of quartiles as quarters. So if we have our smallest and our largest value, we want to break it into 4 equal groups. We're going to have the lower quartile, the middle quartile, and the upper quartile. So the lower quartile, or the first quartile, divides the lowest fourth of the data from the upper third. So you can see here we've got 1 group out of the 4 sections here. 1, 2, 3, 4. It will also be the median or the middle of the lower half. So if I find the exact middle, the lower quartile is in the middle of the bottom. The middle quartile is also called the median. And then we have the upper quartile. So that's going to be the upper quarter, and there'll be 3 sections of 4 below. And then it is also, because it's on the upper side, going to be the middle of the upper half of the data set. We can then create what is called a 5-number summary to give us a good representation of the overall kind of spread of our data. A 5-number summary is going to have the following numbers in numeric order: the lowest value, or the minimum, The lower quartile, sometimes called quartile 1, the median, the upper quartile, sometimes called quartile 3, and the highest value is the maximum. And then what we can do is we have a graph that it visually depicts this number summary. So it will graph all 5 numbers with a box and what is then called whiskers. So the box will be between the lower and upper quartile, and then you'll have whiskers going to the minimum and the maximum value. Going back to the bank data, Big Bank was the one that had 3 lines, and Best Bank was a single line. So what we have here is the 5-number summary. The smallest or the shortest that anyone had to wait was 4.1 minutes. The largest someone had to wait was 11 minutes. And then we divided into all the different groups. So we found the median. So you'll find the min and the max first. You'll then find the median, and then you'll work to find your quartiles. So you'll find the lower and the upper quartile next. We did the same with Best Bank. And then what you'll do is you'll see below here is a box plot. So every single one of these values gets marked with a vertical line to get started. So I'll do this one here. 4.1, you'll see that vertical line. 5.6 has a vertical line. 7.2 has a vertical line. 8.5 and 11. Then the box is constructed between the quartile 1 and the quartile 3. And then the whiskers are created then to go to the minimum and the maximum. And you can see here that it visually shows how spread apart the data is. The larger your box is, the larger spread your data is. And how close it is how much closer your data is together. So this one clearly is a lot closer together. It's going to have less variation than this one here.
Given that you guys have already opened Statcrunch before, I'm not going to show that step or how to enter your data. I trust at this point you guys can follow along with that and understand how to do that. This question wants us to find the mean, the median, and the range for each of the 2 data sets. And then the second part is give the 5-number summary and draw the box plot. So what I can do is I can do 2 sets of data at once. So anytime I want to find the mean, median, mode, range, any of those things, we go back to summary stats on the columns. And I want to do both columns at once. So I'm going to hit shift, and then I'm going to select both of them. Then I can let go of shift. And I'm going to click compute. It is going to give me all the values that I need here in this printout. So what I'm going to do is I will write all of them here for us. So first we're going to do Beethoven. So Beethoven has a mean of 38.8. And we also have a median of 36. And it asks for the range. The range is also in here. That is 42. And then if we do Mahler, the mean of him is his songs is 75. Oops. The mean is 75. The median is 80. Realize that this one didn't. And the range here is 44. So just based off of those numbers, the range is a little bit larger in Mahler's than Beethoven's, but you also have to look at the fact of the overall numbers. Beethoven's songs are a little bit shorter than Mahler's songs. So when we look at the box plots and the 5-number summaries, those are also going to be a little bit different as well. Okay, so next it says in part B, give the 5-number summary and then the box plots. So what I want to do, so 5-number summary is the minimum. So that's there, 26. Then you're going to want quartile 1, which is 30. Then comes the median, which we already had, was 36. Then comes quartile 3. On the very end there is 40. And then the last one is the maximum, is 68. So those are all of Beethoven's values. And then Mahler's values, we're going to do the same thing. So the minimum is 50. Quartile 1 is 72. Median we already had was 80. Quartile 3 we have is 85. And the max is 94. So we have those. Now the next thing we want to do is actually create our 5-number summary. Our box plot, I'm sorry. So we're going to go to graph and we want box plot here. And again, I'm going to do both of them together. So I'm going to hold shift and then click both of the values, then let go of shift and click compute. Now, one thing I forgot to tell you here, that Statcrunch is always going to default go to what is called the vertical version. If you want to make it horizontal, I'm going to do horizontal here. And I'm going to turn this part off just for right now so that we can see the entire box. And here you go. So you can see the minimum and all of those same values should be there. The minimum is 26, quartile 1 was 30, median 36, quartile 3 40, max 68. Those should all match up with what I have from my summary stats. And then I can do the same with Mahler down here. As long as I hover over it, it's going to give me those same values here. It also gives me what's called the IQR. The IQR is the distance between Q3 and Q1. And you can take a look here. So it looks like this first quarter data is really close together. Second quarter is pretty close together. Third quarter is close together. But then it looks like this upper quarter is pretty stretched out. So Beethoven's songs are a lot shorter here, and this he has a 1 or 2 like really long songs. Where Mahler's kind of the opposite. He has kind of this stretch on this left-hand side. So it's going to be pulled down here. This is where the outliers are going to be. And the rest of his songs are longer up here. Now, when I was in here, I told you guys to uncheck this box. That is going to default select and show you what the outliers are. So let me go back and explain that. So what it's going to do is it's going to identify your outliers with dots. There is a formula that we can follow. We're not going to cover that in here. But if you take statistics at any point in time, you'll talk about that. There's a mathematical formula that tells us if we have an outlier. And that's what those dots would represent there. So for our sake, for this class, I want you to uncheck this so that you can draw your box correctly all the way from min to max. So if you want to see that again, that was graph, box plots, select your values, turn this check mark off and turn draw horizontal on, then click compute. And that you have created a box plot.
Another measure of variation that is discussed is called the standard deviation. And the standard deviation is a single number that is most commonly used to describe the variation. The definition of it is really hard to understand. So we're going to kind of talk a little bit about it here. The formula is awful. We don't ever calculate it by hand again. So don't worry about that. But the biggest thing is it's a way to describe how spread apart your data is from the average or that mean value. And the formula is you're going to add all of the deviations from the mean. So every value gets, or we're going to go, I'll show you the steps here, square those values, then divide that by how many data values you had minus 1. We will never do that formula. I will talk you through how all the steps would go through on the next slide here, but you'll see why we don't ever do this by hand. This value-like range, if it is larger, means the values are more variable, they're more spread apart. If it is smaller, it means the values are closer together. All right, so I'm going to preface this by this down here. Note, we will not calculate these by hand. If you were, though, these are the steps you must follow. You would first find the mean of the data set. After you have done that, you will take every data value you have and subtract the mean. You will then take all the values you got from step 1, square them. That means times it by themselves. Then you add all of those values together. Then you divide that by how many you have, minus 1. So if you had 10 values, you would divide by 9. And then the last step would be to then square root that answer. Lots and lots of steps. It usually takes like a table and a lot of time. So we will use Statcrunch to just give us the value and just look at the values and say, if it's a larger value, clearly the data is more spread. If it's a smaller value, the data is closer together.
Now we want to calculate the standard deviation for the bank data. So I have already gone and entered my bank data here. I have big bank and best bank. Again, every time we want these values, we're going to stats, summary stats on our columns. I want big bank and I want best bank. I want both of them. So I hit shift while I was clicking them both and clicked compute. And your standard deviation values are going to be right here. So everything that we are doing here as far as your mean, median, mode, range, min, max, quartiles, it's all in this printout. Big bank standard deviation 1.96 makes sense because it has the larger range. The data values are more spread apart. So the larger the range, the larger the standard deviation. Best bank had a smaller range of 1.2, so its standard deviation was 0.44, meaning that its values are closer together, and which we saw visually with our box plots.
I would like you to try to find the standard deviations for Beethoven and Mahler's symphonies. You should already have the data entered, so you just go back and do summary stats, and somebody share your standard deviations, and we'll see if we all agree. Another way to approximate standard deviation, just because standard deviation is not fun to calculate by hand, would be called the range rule of thumb. So what you can do is you can estimate the standard deviation by taking your range and dividing by 4. It's easy to find the range. Take max minus your min, take that result divided by 4. One other thing that we can do is if we did in fact know our mean and our standard deviation, we could actually then go backwards and figure out where we would expect the range to be. We could figure out our low value estimate and our high value estimate. So if our standard deviation is the range divided by 4, then our low value could be estimated by taking the mean minus 2 standard deviations, and the maximum value could be found by taking the mean plus 2 standard deviations. So we're going to try both of those here on the next few slides. We want to compare the range rule of thumb to the standard deviation for both of the banks and both of the composers. So what we're going to do is we're going to find the range first. So if I went back to the big bank data, the largest value was 11. The smallest value was 4.1. I'm going to take that result and divide by 4. So 11 minus 4.1 is the value 6.9 divided by 4 gives me about 1.725. 1.725 is the estimate. The actual is 1.96. For best bank, the largest value was 7.8. The smallest value was 6.6. So I need to subtract those two values together. I get 1.2. If I take 1.2 divided by 4, I get an estimate standard deviation of 0.3. So again, not bad. Estimate. Beethoven, we had from our printout, we also, let me see, back on slide 10, we found our range was 42. So 42 divided by 4 is going to give me an estimate of my standard deviation of 10.5. And the last one here, back on slide 10, when we did this, the range was 44. So if I divide that by 4, I'm going to get a standard deviation estimate of 11. So as you can see, they're not perfect. They're not going to be exact. It's just a general guideline of where you could expect your standard deviation to be around if you were to calculate it. So the next example is then how we estimate a range. Studies of the gas mileage of a Prius under varying driving conditions show that it gets an average of 45 miles per gallon, so there's our mean, and a standard deviation of 4 miles per gallon. So those are the two pieces of information we need in order to estimate a range. Estimate the minimum and maximum gas mileage you can expect under ordinary driving conditions. So what we have to do is to find the low value, we're going to take our mean and go back to standard deviations. So our mean is 45, and we want to go back 4 miles twice to standard deviations. So we're going to take 45 minus 4 twice, or 45 minus 8, and we could expect on the low side to get 37 miles per gallon. Now working for the higher side, we're going to take that same mean, 45, and we're going to add 2 standard deviations. So our mean's in the middle, 45. We went back 2 standard deviations, and we got 37. Now we're going to go up 2 standard deviations. So we're going to go up 8. 45 plus 8 is now going to get us to 53. So basically, we could estimate on any given day driving our Prius, we should get somewhere between 37 and 53 miles per gallon.